So this section features extraction and matching. This is the title of the section. And we're going to have four presentations here. The first one is colorization by multidimensional projection. It's going to be presented by Wallace Casaca and Eric Gomes, both from ICMC USP São Carlos.
Okay, everybody. Good morning, everybody. And in this presentation, we will talk about the colorization problem in the context of image processing. Our team for this paper is composed by me, Eric, Cynthia, Professor Jovan, Professor Paulo, Professor Fernando, Professor Gustavo, and Professor Afonso. Yeah, this presentation is organized as follows. The first one, an introduction and motivation about the problem. The proposed colorization framework, that's our framework in this case. The multidimensional projection and the user interaction in this context. Okay. Some results and comparisons, conclusions, future works, and special thanks. About the motivation. The problem, there are many applications that use some kind of colorization-based approach in their pipelines. For instance, in this image, in this frame, we can see an example of colorization to color black and white films, movies, for instance. In this case, the classical approach to color a grayscale image, old photos, something like that. Essentially, there are two basic ways to perform this colorization, decolorization. Obviously, there are others in this case, but the classical ways is the following. The first one, the example-based approach. The idea here is to the methods based on example take into account the target image, the gray image, grayscale image in this case, obviously, and a sample color image. And we can do a matching between both images, by sampling this square, for example, the red, blue, to blue. And another case, we can use a scribble-based, where the user perform a scribble directly on the target image, okay? But about the colorization state of the art, they are strongly sensitive to the user intervention. Some drawbacks. The user might provide the matching between the color data and the target image, the image to be colored. The accuracy of the colorization can be tuned only when the input color data are provided by the user in the beginning of the pipeline. And it's not possible to handle the badly regions in an interactive way after the image has been processed. Bon. The goal here, in this case, in our work, is to allow the user intervention before and after colorization by using a visual and interactive tool called Project Color. This is an example of our layout. Okay, the pipeline of our work. The first one, the user must provide the input color data. Feature extraction and feature selection must be applied in order to generate feature space in a high dimension, space. Multidimensional data projection to do this. Pixel classification, okay, and the image colorization, the color transferring must be done in this step. And to finish, we allow the user interaction with the projected data and the colored image. So Project Color allows the use of both strategies. Based on example, we can set color image and to perform a matching between the colored image and the gray scale image by using these samples here. This exemplar or sample, doesn't matter. And based on scribble, the user can provide some scribbles on the target image. About the extraction and selection of features. And the goal here is to building a high dimension feature space based on the grayscale image, okay? So here we can construct a vector applied to each pixel from the target image. This is a point in a high dimension space, and after we perform a selection of the best features to represent this image. So the tools, about the tools to perform the feature extraction, we are using in our approach the Gerber wavelets, LBP, local binary patterns, local scale invariant features, and some statistical and morphological feature descriptors. Okay, there are many descriptors in our approach. So to filtering the features, okay, the first one, why to do this? Well, the first reason, to reduce the feature space dimensionality, okay? Because German, it's a big space. There are many coordinates. And the second, to remove similar and unnecessary features. To keep only the relevant features of the image. To do that, we can use we are using, in this case, Weka is a learner-based feature selection tool. It's very strong. Very nice tool. But, okay, well, about the multidimensional projection and the pixel classification. Well, the goal here in this step is to cluster the target image. The first step is to cluster the target image, and after we perform a decolorization within the image. Okay, the procedure here is to the following: we generate a feature space by using a multidimensional projection technique. that Eric will present after. Sorry. And we generate the feature space in a high dimensional dimension. In a high dimension is a high dimensional space. And after, we can classify this pixel using a pixel classification algorithm, K-means for instance. So here we can the relationship between the clustered image and the points projected in the visual space. We can take this space, project the data in a bidimensional space, in this case, a visual space, and after we cluster these points, and each point here is a pixel here. The idea is exactly that. Bon, now Eric will finish the presentation. Thank you very much.
Well, good morning. As well as was talking, in this stage we have we use multidimensional projection to get a point set clustered. Sorry. Okay. Okay. For example, well, in this case we are using the local affine multidimensional projection technique. That is well, the main idea in this case is to select a set of points to use as control points. This is a sample of the original data set of points. We use some of these points to map the rest of the points. Okay, we use that control points to map the rest of the points, and after that we have to entire map projected, and after that we use a clustering algorithm to get a clustered data set, and as well as present the result of these steps is a cluster image or segmented image. After that, we have the final step, that is the image colorization step. In this case, we mainly chose the more similar pixels between the target image and the source image, based on the luminance metric. This is the luminance. And after that, we have the match between this image. And after that, we apply, well, we copy the alpha and beta channel to the source, from the source image to the target image. About the user interaction, the main contribution in this approach is that we are using an interactive multidimensional projection in the context of the image colorization. It allows to improve the colorization result by using a drag and drop of the widely colorized pixels. It allows to modify the cluster by interactively manipulating of the projected data in the visual space. This figure illustrates the interaction in our approach. In this case, for example, we are selecting some points, and that points are a data set of pixels of the target image. as we can see in this case, in our technique, it's possible, allows to add a badly colored pixels as control points. In this case, we add in some pixels as control points and generate again the multidimensional projection to get a best clustered map. The result is a best image, a best colored image. Well, to finish, we have to present, we want to present some results and comparisons. The first, interactively improving the colorization results is one of the results. Okay, in this part of comparison, we are comparing our technique with three state-of-the-art techniques. In this case, we are comparing with example-based approach. With an example-based approach, we have another technique that is an scribble-based. Finally, we have to we will present the result, the comparison between our technique and this technique. That is an example optimization-based approach. Okay, the first one. In this case, we use an example-based result. Okay, this is our source. We select two regions to do the match with the target image. This is the result of the multidimensional projection. After that, we're coloring this image from the result of the multidimensional projection, and the result is a colored image. This is the same image, but in a scribble-based way. In this case, we use a different color in order to highlight the result. As we can see, where scribble in these cases, and the result is as we can see. Okay, in the case of the result with the user interaction, we are taking this image as a source, this image as target. We have the dimensional projection, and after that we have some points that are clustered in a wrong cluster. After that, we have the user have to interact with the multidimensional projection in order to improve this segmentation. And after that, as we have a good result of the segmentation, the colored result is a good result. This is the result using the scribble way. Okay, we have one result more. In this case, we're taking this image as a source. We're matching this image with the target image. This is the result. As we can see, we have some points here, here, and here that are clustered in the wrong cluster. It's a bad result. After that, we have to select some of these points. As we can see, we select these points, and we generate again the multidimensional projection. The final result is this result tuned. Okay. Okay. We have a scribble-based image here. we are comparing our result with two approaches. As we can see, the Levin method and the running method have well, in the case of the Levin method is a very weak result. And in the case of the ironic is a better result, but have some troubles here. I can in this part, for example, of the left is in green, but the original color will be in the same color of the tiger. And our approach improved that result. The same case is with this image, where doing the match, and the result, it is our result, the project color result, and is the result of the wedge method. In this case, is the Levin method. Conclusions. Our technique introduces the use of interactive multidimensional projection in the context of the image colorization. It's an intuitive, robust, flexible project color, provides an easy layout to user interaction. Our technique can be used in both cases, for images having high concentration of textures or images without many oscillatory details. We allow the users intervention to improve the final segmentation colorization result. The next steps in our future works is turns the colorization a process totally automatic without the user intervention, and turning the tool to process high dimensional images. And that's all.
Thanks, Wallace and Eric. So questions?
Congratulations, very nice work, nice results. I just have one question. Can you do the colorization with more than 2 patches? Because all the examples you showed, you have like two very neatly separated regions, like the grass and the sky, the grass and the tiger. If you have like more than 2 clusters, is that a problem? Because usually clustering is kind of a hard thing to do. When you have only 2, it's less hard. It's not that it's easy, but when you have like more things, if you put another object and there's clearly a third thing you have to color, is that a problem? And if it is, what is the? I imagine it's clustering, but you tell me.
Okay, in our approach, it's not a problem because the multidimensional projection is a tool to map high-dimensional data. So we're tested the multidimensional projection techniques because we work with multidimensional projection techniques, and in a lot of cases we are using 3, 4, 5, 6, and whatever number of classes, and there is no problem.
More questions? No? I believe I'm not supposed to ask a question to a paper I'm co-authoring, so let's thank Wallace and Eric again.